So, hello everyone, and good afternoon. I think we can start already. Hello, Daniela.
Hi.
So, good afternoon and welcome to the fourth IDS 2024 webinars. We are happy that we are with us today with this interesting lecture. I want to tell the people here that we had previous events, and they can take a look at IDS website, and there you will find the videos and of the previous webinars and interviews. So you will also get a copy of the presentation and the video as well for this webinar. So hello, Daniela, how are you today? Thanks a lot for being here with us.
Thanks to you, Miriam, for the invitation.
Okay, so for those who probably, I doubt, sorry, I have to admit people, and I have to do many
I'll help you
at
admitting.
the same time. So just wait 1 second for me to arrange something, and I will be with you. So Daniela, here, Daniela Vidal, she actually started her professional career in the water sector in 2006. And from the day one, she discovered that it was her passion. So we already feel a little bit like you. During her career, Daniela has accumulated extensive experience in the water treatment industry with a specific focus on membrane systems. Her years of technical and sales experience have provided her with a deep understanding of the sector, allowing her to offer optimal solutions and have helped her to improve the efficiency of desalination plants of her clients. In 2019, she started working with H2O innovation, and currently she holds an important position as the regional sales manager for H2O. Today, Daniela will provide us with some valuable tips on how correctly applied chemistry can address issues in seawater reverse osmosis and prevents biofouling of RO membranes without the use of oxidant agents and biocides, thereby avoiding the risk of membrane damage. So, one additional sentence before we start. I want to remind you, I see everyone has closed cameras, and I want to encourage you to send questions at the chat so Daniela can answer at the end of the presentation. So again, thank you all, and thanks to Daniela. The stage is yours. Muchas gracias.
Thank you. Gracias. Thank you, Miriam, for the introduction, and thank you everyone for being here this afternoon, late afternoon. So today I'm going to talk in this webinar on how we can, or how chemistry, the correctly applied chemistry, can help all of us to solve problems in seawater aero plants. I will start. One sec. Okay. Okay. First, I would like to introduce you a little bit about us in case that you don't know us. So H2O Innovation, it's a Canadian company. And inside H2O Innovation, this company, what they do is they design and they build systems in North America. They also have some operation, but we do also have a specialty chemical and products pillar, where we have different type of products and service to offer to all our customers. So regarding the specialty chemicals, we do have different type of antiscalants, cleaners, preservatives, biocides, and some filter aids. So we have two range of chemicals, I will say, because we are two companies inside H2O Innovation. So we are Genesis and PWT Chemicals, with two different manufacturing sites, one in UK for Genesis and one in USA for PWT. So all these products that we have are covered by these two companies' brands. Okay, so we have all these specialty chemicals. Apart from that, we have the projection softwares that will help us to predict the scale potential with a particular water or a design. And with these softwares, we can help to optimize the dosage and the recovery of the plant, not the operation that of the plant. We also can help providing some analytical service, and I will talk a little bit more about this, with membrane autopsies, with foulant identifications, with some chemical cleanings off-site and inside cleaning in place. And then we have we are working with strategical regional partnerships with a worldwide distributor network all over the world. So in case that you are working in a project in a different country, in a different place, we can also help you with local support. Okay, the same is the case for Israel, with the local stock of the product and the local support of our partners. Okay, now getting into the details of the presentation, let's start by talking about what type of chemicals are used in a seawater SWRO plant. So first, I will talk about the antiscalants to prevent the scale. We also have cleaners to make the CIP. These cleaners could be high, moderate, and low pH. It could be in different forms, could be powder or liquid. Could it be SWRO cleaners or UF, NF, or cartridge filters cleaners. We can also have flocculants and coagulants. We do have non-oxidizing biocides. We have biofilms inhibitors. We have some chlorine reducers, corrosion inhibitors, and membrane preservative. Okay, how can all these chemicals that I mentioned before, how they can help solve problems in a seawater desalination plant? So first, with antiscalants, we can prevent the scale of the membranes. We can, with that, work in a higher recovery. We are able to clean the membranes. Most important than clean the membranes, also to prevent the cleaning, prevent the biofouling, prevent the oxidation that will damage the membranes, prevent the corrosion, maintain a high flux on the system, reduce the pressure drop, the delta P, reduce the energy consumption and all the costs that are related to this energy consumption, reduce also the cartridge filters replacement, the frequency of what we are replacing them, and reduce the biogrowth in product water storage tanks. So in today's presentations, I will mention 3 different topics. First of it, one big part of the chemistry that we are using in these plants is the antiscalants. So I will talk a little bit about the super concentrated antiscalants. Second, some membrane cleaning strategies, and also a little bit of a comparison between the commodity cleaners and specialty chemicals. And third, the product that Miriam was mentioning, one product that we have to help with the biofilm that works as a biofilm inhibitor. Okay, first part, the super concentrated antiscalants. Just a fresh reminder, I think everybody here knows that, but just to make a refresh on this. So this scheme is the basics of the scaling in a seawater plant, in any plant, I would say. So we have the feed water, we have the lead element, and we have different stages, okay, of different elements. So when this water is running through the system, we have an increase of the concentration of the ions in the brine, while the pure product or the permeate is sequentially removed. So what will happen on these tail membranes elements? So this high concentration of these rejectants ions will be most likely on this concentrated, not on these elements. So we can find, for example, calcium, magnesium, sodium, bicarbonate, sulfates, silica, and some transition metals, depending on the feed water that we have, the concentration, and many other factors. How can we prevent or avoid this? So using an antiscalant, and from the antiscalant, we have different families here. We do have, but we have two main biggest families. One of these type of antiscalants is based on phosphate, phosphonate. So these products usually have low molecular weight, and they contain phosphorus on their formulation. They are good on the scale control in highly scaling water. So we have different examples of types of phosphonates, like ATMP, DTPMP, etc. And we can have them working alone or in combination or depending. So this is going to be the first family. The second family is the polymer-based antiscalants. Okay, this has usually a higher molecular weight compared with the phosphonates. They are ideal also for low scaling waters, or depending on what we are treating, they're effective controlling silica, sulfates, and other things. So we have different examples like copolymers, terpolymers, or the dendrimer that I will talk a little bit. This is a molecule that we are synthesizing. Okay, and ideally both have the same properties, so they are both families designed to help and prevent scale. So the idea is that we'll choose the best one depending on what we are treating. No? In different cases, we can also work with the combination with this type of chemistries. So just mentioning a little bit about the dendrimer-based antiscalant, because I also think that the most known for everyone are the phosphonate-based ones. So I'm not going to talk about them in this presentation. So I'll focus a little bit on this dendrimer-based antiscalant. And you can see here one graphic of the normalized data of a seawater desalination plant, where you can see that during a period, the plant was working with a phosphonate antiscalant, and another type then start working with the dendrimer antiscalant. And what we are seeing is that actually both kind of products are working in the same way and helping to maintain the normalized flux and the delta P of the plant. So, but what could be the difference? No, why choose one or the other? No, so I'll focus a little bit on some advantage of the dendrimer. So this is our own formulation. No, actually the chemistry is the dendrimer, but the product it's called SpectraGar 111. So this is a super concentrated formulation that what we are doing, we say it's 11 times super concentrated. So what we are doing is, instead of shipping a full container of product already diluted, we are sending less amount of product. We are sending that to the plant. All the desalination plants, you already have a great quality water, the permeate water, to make the dilution inside. So doing this, we are going to save CO2 emissions, we are going to save in logistics, transportation, and the storage of the product. Besides this, the type of the concentrated that we have, it's also, the product is 100% phosphorus free. So at the end, we will have low phosphorus in the brine discharge. Okay, so this will help also to reduce the algae blooms in the brine discharge, depending on, well, in the zone that we are making the discharge. So we're talking about environmental advantage here, more than the performance of the product. Okay, then apart from the antiscalants, we also have to think about the cleaning strategies. And I will go slowly in this graphic that I think many people, well, maybe you have seen this before, okay? But we need to keep something in mind, is that the membranes, they will fall as soon as they come into service. So as soon as we start a plant, the plant starts in operation and the water starts running there, so those membranes will start to fall. So we are putting here on this graphic this perception threshold. Okay, let's see that this is the threshold or where we are going to notice that something is happening on the plant. Okay, so as I said, we started, and since the beginning, we are going to have some unseen falling, but the membranes will start to fall. Okay, so these falling rates, they increase as cake layer forms. Okay, so we are going to have like different cakes on the membrane, but we're only going to notice that when the delta P or the delta P increase or the permeable flow decrease. Okay, before that, we're not going to be able to detect any symptoms, but the falling, it's already start to happening. Okay, so what is usually happening? Now, the membranes manufacturers, they recommend to clean after 10 to 15% of deviation from the design specification. So we get to this perception threshold where we see something is happening, but we wait until we have the 50% increase on delta P. And maybe not even though, because we say, no, but the flow, it's okay, so let's keep a little bit more, and you wait until you clean the plant. So when you're doing this, what you are doing really is a reactive clean. So you clean, you recover until a point that is below this perception threshold, but you still have folding there. Okay, so we wait again until we have a 15% increase, and we make a second reactive cleaning, and we keep going this way. Okay, but the membranes will never be as clean as they were new. This is for sure. Okay, so this remaining foulant is compressed into the membrane surface, and this foulant will continue to increase. If you see this line here, okay, even though we're recovering, we are not getting to the same point as the first reactive cleaning. Now this is, you see the tendency, this is going to keep increasing. What we can do, imagine that we can do, that it's not very common, but we really highly recommend this. Before we see anything, the plant started in operation, everything seems to be working well because we are below this perception threshold. So we are not seeing any symptoms. So we perform an autopsy in this point. When we make this autopsy early, we can identify exactly what type of foulant we have on that membranes and the best way to clean it, okay? So we make a predictive clean. You see, just when a small symptom is happening, we make this predictive cleaning, and we can recover much more of that plant. So how we can do that? No, we say that we can always keep some CIP chemicals ready on site because this is the other thing that it's happening. Usually, maybe you see an increase, you are going to make a reactive cleaner, but once you decide to clean, once you buy the chemicals, they arrive to the plant, you schedule when to stop the plant and to do it, it's even later than it was when you think about it. Okay, so it's important also to keep some CIP chemicals on site ready to make the clean, and clean as soon as the foulant is perceived on the system. So I mentioned to make this autopsy before, no, so, wait, sorry. So this autopsy, this is something that we can help also, as I said. So what are we doing with this autopsy? It's not just send a full membrane element to our labs, we open it and we make the analysis of it. So first we make an external inspection of the membrane. We see if they have any presence, particles, deposits, damage. After this external inspection, we go and make an internal to detect the presence of foulant, particles, or any failure on the membrane surface, the spacer material, the glue lines, etc. After we take that foulant, we make the identification of that. So we are making different type of analysis to see what do we have on that foulant. We can also study the membrane performance parameters, so the flow rate, the salt rejection values of different compounds. We have a blood test rings where we are measuring this. And we are making also the integrity test, okay, to analyze the integrity of the membrane. And if you also want, we can make the cleaning test and study and look for the most convenient combination of products to remove the foulant that we found there. So you have different levels of autopsy. So you have a basic ones and you have a full level of autopsies where we can check everything and help you with the cleaning test. So we have conducted over 2,200 different type of autopsies for different types of waters, plants all over the world. So we do have also good information and knowledge on how to do it. And for your information, we have different labs where we can do it. The one in Europe, it's located in Madrid, in Spain, and another one it's located in USA, in Vista, okay? Also, in any time, if you want to perform an autopsy and you want to go and check how we are doing, you are more than welcome to visit us. Okay, so let's imagine that we have that full report, what the membrane has inside and outside, and we detect the best combination of cleaners to clean that plant. So, and we have the chemicals on site, and we are going to clean, as we said, as soon as we perceive the foulant. What will happen is that we are not going to reach that reactive cleaning, okay? We are going to keep on this predictive cleaning, A, B, and the time between them is much longer than if we are working in a reactive way. At the end, we are going to reduce the fouling rate after each cleaning. This is how it looks like when we act with a reactive cleaning. You see, we had 3 reactive cleaners, and we are almost on the perception threshold, but when we are working on a predictive way, here we have only 2 cleanings, okay, and we are recovering much more of the membrane. Because also when it's not that big cake that it's already formed, so this foulant is going to be much easier to remove. Now, talking about energy, the first picture is a new membrane. Just open the new membrane. So we are saying that the consumption, the energy consumption in a seawater desalination plant is around 3 kilowatts per cubic meter, but this is going to be with a new membrane, okay, when it's like that on the first picture. But what will happen if we have a membrane that it's already full, like this one, or full of scale? So we are not going to need the same energy to help for the water to pass there. So at the end, we are going to need a higher pressure to produce the same amount of water. So this is also why it's important, no, to make predictive cleaners or to clean efficiently to do not increase the energy consumption of the plant. Talking about fouling, this is some examples of what you can find. No, this was also a seawater desalination, or this is a seawater desalination plant that it's cleaning in a predictive way with Genesol 704, which it's an alkaline cleaner. And you can see that the normalized permeate flow had an increase of 12%, and the delta P a reduction of 36.4%. But the most important, besides these numbers, is that the electricity consumption per cubic meter of permeate produced was reduced in 6%. Okay, then how to clean, no, and how to avoid the damage on the membranes. Sometimes when we are cleaning with commodity cleaners or caustic, etc., we are making more aggressive using more aggressive chemicals. So first, we always have to use membrane compatible chemicals. And second, we need to check the manufacturer's cleaning guidelines and regardless to pH and temperature. So in these two graphics here, the first here on the left, this is some analysis that we are making, the tensile test curve, in this case in a aero membrane. So you can see in this first, this was cleaning with a specialty chemical. So you see here, this is the load in Newton and the deformation of the membrane. So it takes more time and more load to cut, no? like the membrane, no? To have that deformation. But when we are making that test, but using or cleaning that membrane with sodium hydroxide in more aggressive conditions, you will see that we are using less load in newtons to have and getting a smaller deformation of the membrane. Okay, so they are breaking easily and faster. Another thing that it's important to take into account, no, talking about the antiscalants and the cleaners also, is the critical role of using permeate or softened water for an effective cleaning process. So this is a video that it's not working in this PPT, but I will show you. This is a very recent video, and I think you will see it clearly if you can identify what is there. Okay, so if you saw it, let me come back to presentation mode. 1 sec. So this was basically one sec. I cannot do this.
We cannot hear you. You are in mute now, Daniela. Daniela, you are on mute. We are on mute. You have to open your microphone. Open your microphone. It is closed. I don't know.
Now, okay, now, can you hear me now? Can you hear me now?
Yes,
Yes, we can.
Okay, sorry, it got stuck. Just to show you the video, okay? I hope you saw the video. Did you saw the video? The video was working,
everything
okay?
is okay now. We saw everything. It was perfect.
Okay, thank you. Okay, so in that video, what we had was actually it was one plant, that a seawater plant. It was that they were making a seawater cleaning with an alkaline product, but instead of using any permeate water or good quality water, they were cleaning in this case with the seawater, with the feed water of the plant. Okay, and we have some precipitation with the combination with the high pH of the solution, and you can see, well, we have some precipitation of magnesium and calcium on this. So it's really important, also a part of the chemicals that we're choosing or using, to use the correct type of water to make the dilutions. Okay, so here, this is some graphics, some studies also that were done using, for example.
Sorry, Daniela, we keep seeing the video. I don't know, maybe you have to go back to the presentation. You wanted to show the presentation again?
Yeah, maybe I'll do that. Okay, 1 second. Let me share again. Now?
Now it's okay. Perfect.
Okay. Okay. Okay, so what we saw on the video, basically these are some numbers with the same situation, not in that particular plant, but it's actually mostly the same. So we have a solution with 0.5% of caustic and 500 ppm of magnesium, and a formulate chemical with 1% concentration and 500 ppm of magnesium. So we are seeing here in the spectrums, that actually when we are cleaning, imagine that we are cleaning here with feed water, with the seawater solution, or we have some fuels into the system of this water instead of the permeate water. You can see here that the magnesium level is higher when it's in combination with the sodium hydroxide, and compared to the one that we have using even a higher concentration of a formulate product. Okay, so this is just to show you a little bit how it can work depending on the water that we are using to make the dilution with an alkaline product, in this case an alkaline cleaner, and how it's working in this case better, even if we are using, for any reason, that type of water, using a formulated product instead of caustic. Okay, so it's important also to know that the foulants, the composition, it's commonly composite, so it's almost impossible to find only one pure foulant when we are making an autopsy of the membrane, because the 38% of the membranes, they show a significant presence of a secondary foulant. Okay, so this is important to keep in mind, that when we are cleaning one thing, we are also having some secondary foulant or potential problem on that membranes. So according to all these autopsies that I show you that we are doing in our lab, so the main foulants components that we are detecting in first place is always the biofilm, organic matter, and then in second place, colloidal matter and particulates. Okay, this is on this graphic on the left. But you can see here that we also have these secondary foulant components. So when we say that we do have some organic problem on the membrane, so we are having colloidal matters, but we are also having some scale, we are also having some metals and some part of organics. Okay, same situation with metals, scale, colloidal matters, or biofilm. It's never only one component alone. So we need to address all the things that are happening into the system or all the foulants that we have there. Okay. So this is some foulant composition, but in the ultrafiltration membranes. Okay. Again, in ultrafiltration also, the biggest percentage that we have is biofilm, first place, and organic. Okay, but it's also, we're also finding some secondary foulants components. Okay, so if we have, as I say, biofilm, we also have colloidal matters, calcium carbonates, metals, and other type of scalings. Okay, so you can see here how the split is of the different type of foulants that we can have. Okay, some examples. So I said the most common that we are finding always is biofilm and organic matter together, and plus with some clays and colloidal matter. So this foulant is particularly difficult to clean, okay, especially if we are working as a reactive cleaner instead of preventive cleaners, okay, because it gets compressed, you know, with the pressure. What we can do, we have some formulated multifunctional cleaners. So the idea is that in only one product, you can have all these multifunctional properties of the product with detergents, chelating agents. They are going to increase also the osmotic pressure, surfactants, buffer pH. So these products are 100% active. At the end, you're going to use a lower concentration, and is effective when we are cleaning composite foulants. So as the ones that I mentioned before, the difference when we have the principal and the secondary foulant. So we have shipping savings for the concentration of the products and savings in the stock area. Okay, so some few examples of these. If we have, for example, aero plant with biofilm and colloidal matter removal, so what we are doing is to try different type of formulation F1, 2, 3, 4, 5 different types of formulations, and we are comparing this by using some commodity cleaners, for example, the mixture between EDTA and SCPP. So this mixture between these two commodity cleaners, they show a good increase in the flow, but it's smaller if we compare it, in this case, with some formulated products that it could be the formulation 5, no? So it's important always to choose the best formulation for each type of foulant. And this is another case in an aero plant also with biofilm, colloidal matter, and also have some calcium carbonate. So you can see here we clean only with caustic with different type of chemistries, some formulation 1 formulated product, number 8, the combination between 8 and 9. So we are always trying all the possible combination that we can have. So the permeate flux increase was only obtained when the sodium hydroxide was applied alone, not when we apply it in this case with another type of commodity cleaners, but we achieve better result, of course, when we clean in this case with the formulation 8, okay? And this is only talking about the flow increase. Okay, so In this case, it's the same. So one aero plan in a seawater plant with biofilm. We said this is the main problem that we are having. So we are trying, for example, if we can, and we do have the opportunity, so sometimes we are making different autopsies in different years to follow the performance of the plant and seeing if we can improve something. So in this case, we are trying also different formulated cleaners in our product range. And you see that sometimes even what we are trying is to say, okay, instead of increasing the concentration or announcing, maybe we only need to increase the time, the contact time of the plant to have better results, okay? And we do also compare it in case that for example, if you are using caustic, not to see the difference of this performance. This is an UF plant, okay, that has some biofilm, iron, zinc, and another type of components. So here the same, we clean with citric acid, for example, and with different type of formulated cleaners, also with caustic, and we compare the difference, where we are getting the better flux increase for this type of membranes. Okay, in this case, the formulation number 3 of the product. Okay, this is another test that we did for the UF membranes, biofilm with some iron also, and you can check here when we were cleaning with UF12, this is one of our cleaners, okay, only with the recirculation, the flux was increased in the higher level, we don't even need to make any backwash with that because we recover enough with the recirculation using this UF12. So in comparison of using the caustic, okay, or the EDTA. This is the last one. The main foulant was biofilm, and then secondary foulant, some aluminum silicates and iron. The same case, okay? We tried with different types. We tried with citric. This is what we were comparing also, and this case NSO 704, and we saw that for this membrane we got the better result, the better improvement on the flux. And the last part of the presentation, this was then point number 3, how to prevent biofilm. Okay, so I'm going to present you this Genesol lady, which is a biofilm inhibitor product. But before talking the product, I will talk about biofilm. You saw how many membranes or percentage of biofilm we are having or seeing. So aero systems, they are really a good place to live. They have high nutrient availability and any threat for any other higher organisms. So what will happen here on this membrane, we are going to have an exponential growth of the biomass. We are going to increase the feed pressure and reduce the permeate production. So once we have established this biofilm, this EPS, that is a mixture of the dead and alive microbial cells, when this biofilm is established, so we are going to need to kill this. If we kill this living microbial, that doesn't mean that we are going to remove the EPS. And the biocide alone is not enough to restore the membrane performance in a biofilm system. Okay, so some things and symptoms that we can find to detect in case that we are not doing an autopsy. No, if we are doing an autopsy, we are going to see it clearly. But some signs is that permeate production will decline. We are going to need a higher operation pressure. The cell rejection may increase because we have this additional barrier. Another signs, if we are not making an autopsy, but we remove the elements and we weigh them, so you can see that the late elements could be higher than 18 kilograms, and they will smell. They will smell a lot, when you remove it from the pressure vessel. How we can prevent, not eliminate, but prevent this biofilm to happen here? So first option, we can inoculate the feed water with a biocide or using some specialty chemicals. Second, we can remove the nutrients, but this is quite expensive to remove all the nutrients on the pretreatment. And three, to make some regular CIPs that will require some planned downtime, and we are also trying to avoid that as much as possible. So we'll take the first option as our preferred option. We'll talk about how to inoculate the feed water by using these specialty chemicals. So we have some oxidizing biocides that could be like chlorine, bromine, ozone. They are effective destroying the cells and the EPS. Okay, they generally act fast, but they will require more time for thick deposits. Excess required for effective biofilm removals. So, but these strong oxidizers, they can degrade the polyamide membrane, so they must be reduced before entering into contact with the membranes, okay, using SMBS. We also have some non-oxidizing biocides like acetylsolons, CVMPA. They are more slowly, they require maybe long contact times. They help to decrease the microbial population, and they help to weakness the biofilm, but their ability to remove the EPCs is limited. And this can also be an expensive treatment, and these microbes can be resistant, and unaffected. Okay, and we do also have some health, safety, and environment concerns for many plant operators that many non-oxidizing biocides are sensitizing. Okay, so this Genesol 80, so this is a biofilm inhibitor that will penetrate directly this EPS and disrupt the biofilm forming bacteria. It's going to be effective when you dose it without any conventional biocides. Okay, and what the product will do is to reduce the adhesive force between the foulant and the membrane surface, okay, discouraging further biofilm attachment. This is going to help to avoid the biofilm, but not the scale, okay, so they are compatible with any of Genesis PWT antiscalants. Some ways to dose this product. So you can dose it. You can use it in a CIP, for example, to help during the CIP process. But I'm going to show you one case study where we can use it or in continuous basis or semi-continuous basis. Okay, depending on how the system is designed or how much we need to do it. Okay, so we can continually dose into the aero feed. It will prevent any opportunity for biofilm to establish, and it's preferred for feed waters with high biological load, okay, when we are dosing it in continuous. If we go to the semi-continuous dosage, we can make different chunks per day, different hours. It's a cost-effective solution. The idea is to reduce the chemical use, and it's preferred for small plants with lower tendency for biofilm to form. So this is some case study. Okay, you can see here, this is a tank. You have a sand filters, activated carbon, cartridge filters, and then the row plant. So this was the first scheme. Okay, they were using hypochlorite and then SMBS, the antiscalant, and also some acid. We did different things here, okay, but I will focus only on the Genesol 80. So they were having frequent cartridge filter replacement, frequent cleaners every week with a high membrane replacement, and the operation was below the design capacity. So what was the method? They were cleaning aggressively the membranes. So we revised the chemical dosage scheme. So for doing that, what we did first was to adjust the antiscalant, remove the acid, okay? And we remove, as you see here, the dosage of the hypochlorite and the bisulfite, and start the dosage of Genesol 80, okay? In these two points. So the results of that plan was first, we removed the use of 3 chemicals, okay? The acid was related to the antiscalant, but related to the Genesol 80, we were able to eliminate the use of hypochlorite and sodium bisulfite, and only those the Genesol 80. Besides that part, the results on the plant, okay, is that we gain the increase on the permeate flow of the plant was 32%, and we also increased, this was because we increased the recovery from 46% to 64%, meaning a 37% increase on this recovery. No, we can make all the calculation of the cost saving per day, okay, of this water that was saved every day, and the annual savings just related to this was around 10,000 pounds. Okay, so the conclusion for this presentation. So first, I talk about the super concentrated antiscalants, and particularly the dendrimers. So we said no, they are both working way good to avoid any potential scale. But the super concentrated polymer antiscalant is environmental superior, in this case to the phosphonate products. Second, cleaning membranes early in a predictive way. And with the right product makes it better than leaving it until it's too late. Okay, so we also need to consider when we make any cleaning procedure that it's very important to use the right chemicals, okay, that can help us to win more, to recover more on that plant. So these formulated cleaners usually contain some mixtures of components that will provide us all the necessary multifunctionality that we are going to need to eliminate not only the first foulant, but also the secondary foulant that we have. Okay. And third, the non-oxidizing membrane compatibility biofilm inhibitor can reduce the operating cost of the plant. So that was it. Here you have my contact details. This is my LinkedIn profile, my email. In case you have any question that I cannot address here, we can talk anytime you need.
Hi, thank you very much.
Thanks to you.
Thank you very much for this interesting presentation. Thanks a lot for all the tips we got. So I'm sure people will got a lot of insights, and we understand that we have different tools to understand the performance of the membranes, to understand how to keep a high performance. First, as you said, by detecting even before it's detectable any fouling. So you are proposing the autopsies with cleaners, and then at the end with a very interesting solution that I understand that is an additive to the antiscalant.
No, it's not with the antiscalant, it's another product. So you are going to use this Genesol 80 in case you have some biofilm potential. But apart from that, the antiscalant. They're
Oh,
still not together.
so very, very interesting to see all the possible solutions or handling and the products. And here we have some questions. Sharon Zamora is asking if we are below perception level and we are not feeling it. So how do we know the cleaning was effective? Because actually you didn't know how much it was affected.
Yeah. No. Yeah, that's true. No, but I think you are going to have some symptoms. No, if we make this predictive cleaner, if I show you, we were just a little bit up to this perception threshold where we saw something is happening. No, maybe 2% increase, but not the 15% increase. This is what we are saying. No. So when you clean, you are going to see that decrease on the system. But it is not to wait until you already have the 15% difference. Okay.
Okay.
And also with the frequency, no, at the end you will see that.
Okay.
I guess no, this is an ideal dream, no, but
yes, maybe based on any previous experience. So you start to doing that or in a new plant or an expansion. So you are already aware of that.
Exactly.
So Sharon, I hope the answer is clear. If not, you can continue reacting. Amit Taberman is asking if we can also detect the amount of scaling up by detecting the brine electrical conductivity. And also another question, to overcome the issue of biofouling during the process, can we use ozone or chloride as pre-water treatment before goes on UF? I think you answer a little bit about that. But, if you can elaborate a little bit.
Yeah, going from the process can use the same separate treatment before goes on the UF. Yeah, but this is what we were saying, no? This is the oxidizing biocides. Yes, sure that you can use it, okay? But the solution that we are thinking here was to eliminate all this type of oxidizing biocides and to use this biofilm inhibitor, okay? It's a different type of treatment.
I see. Okay.
Yeah, where it's more common to see folding first membranes always. Okay, it's the most common to see it always on the first elements of the system. Okay, this biofilm will stay there.
Okay. Then Elena Gelman is asking if Genesol 80 is possible to use instead of acid when we use the acid to avoid calcium phosphate precipitation.
I don't think it's the purpose of the product. Okay, maybe what we are going to need is the antiscalant to elaborate on the antiscalant dosage here to avoid the calcium phosphate precipitation, but the purpose of the Genesol 80 is to avoid the biofilm.
What is the pH of the Genesol 80?
It's an alkaline pH. I don't remember exactly. Yeah, it's an alkaline pH. Don't remember exactly the number.
It gives okay. And then Carlos, hello Carlos here. So as he said he had to leave. Okay, bye Carlos. So I have a question.
Yeah.
How so maybe I will my answer will be oriented to Genesol 80 and to all the chemicals, because first of all, what do you do? How can you discharge your chemicals, your cleaning chemicals after CIP? What in terms of environmental issues?
Yeah, I know that we're working really close to some of of the plant here. I know that particularly in Israel, we do have some regulations very restrict on the discharge of the organics. So we are trying in this way to actually to find we're not looking also into the best solution for the recovery of the performance of the plant, but also to be into the limits of the discharge. In this case, for the Israeli regulations. Okay, so this is the way that we are doing. We are combining different concentrations or time or products to help with that. In other places, we only neutralize the solution and just discharge it. Okay, without any other problems.
And my last question is, you show an interesting application. It looks more like industrial coolant. So my question is if I know part of your chemicals has drinking water approval.
Yeah, they are NSF approvals.
So also
Genesolate, it's NSF approval also. So listen, yeah, so you can use it for any potable water plant. So yes.
Okay, so if there are no further questions, so we can finalize the meeting now.
Any other question that you may have in the future, anything, please just send me an email. I'm happy to help.
Very good. So in the presentation, we also have your email address, and we will be sending also a link to see again so the presentation. So thank you very, very much. Thank you to all the participants for joining IDS again. תודה רבה, ומקווים לראות אתכם בוובינר הבא. And so we hope to see you all in our next events. And thank you very much.
Thank you.
Daniela and
Thank you, everyone.
Bye-bye.
Thank you, everyone, for being here. Bye.
Thank
Thank you very much, Daniela.
Bye-bye.
Thank you.
Bye. See you. Bye.